Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on regression and correlation using some alien data. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this set of videos, and this is part 4 of the series. And we're ready now for example number 3. And we have some male data, alien data, and we have added IQ at the bottom of our list as well. So we have height at 4.06, 4.25, 4.37, 4.46, 4.82, 5.13, and 5.20. We have the weight in pounds of 87.3, 89.8, 88.7, 89.9, 92.5, 93.4, 94.3, and the IQ of 200, 221, 216, 203, 202, 220, and 191. First of all, we will look at weight versus height. That means our weight needs to be our vertical axis and our height will be our horizontal axis. When we say weight versus height, that's weight as the vertical, height as our horizontal. Remember from our previous example, we had already done this in a previous in part 1 or 2, I've lost track. The X is height in feet and weight W is weight in pounds, and you can pause and re-enter this data for yourself and get the 2 screenshots that are here to the left. This is our scatter plot and our linear regression. So what is the correlation coefficient? Well, our correlation coefficient is 0.9727. Again, Mrs. Borlaug rounding to 4 decimal places. Based on the scatter plot and the correlation coefficient, is there evidence of a linear relationship? To determine this, remember that we will need to state the critical value from the table and explain how we used it. 1. The scatter plot, the trend appears to be linear. And then the second step, with our n equaling 7 paired set of data, our critical value is 0.754. And our correlation coefficient is r equals 0.9727. And since the absolute value of r is greater than our critical value, there is evidence of a linear relationship. So, since we have a scatter plot that tends to be linear and the absolute value of r is greater than our critical value, there is evidence of a linear relationship. And is it appropriate to use a linear regression equation to make weight predictions within the range of given height values? And if not, what should we use? Well, yes, it is appropriate based on the scatter plot and our critical value table. And since it is, we don't have to answer the second question. It's not applicable. So in this case, remember that I don't know if this was, I'm a little lost here. It says D, but we're going with the flow. Find the regression equation. So to find the regression equation from our screenshot, we have our 5.7009x plus 64.5452. We did this earlier. And so that gives us our A and our B, and that's where we got that information. And that's the height and that's the weight. And we kind of skipped earlier making that decision of why it was appropriate to use this equation to find and make a prediction. In this case, we are going to make a prediction for the male alien that is 4.7 feet tall. Remember earlier we made one for 4.5 feet tall. She's put the wrong equation here. This is for the female data, not for the male data. Remember that we're using the equation 5.7009x plus 64.5452. And we will place 4.7 in place of the x because x represents the height in feet, and this is 4.7 feet tall, which is the height. So we will replace x with 4.7 and calculate that, which will give us approximately 91.3 pounds. 5.7009 times 4.7 plus 64.542 gives us 91.3394, or approximately 91.3 pounds. Next, let's look at IQ versus height. That means we'll put IQ on the vertical axis as our y and height as our x. So in your calculator, height will be in list 1 and IQ should be put into list 2. You will need to pause and work that out if you want to work it out by yourself on the calculator. I hope you did pause and do that. Here are the two screenshots of your scatter plot and your linear regression screen. What is the correlation coefficient? The linear correlation, or the correlation coefficient, is R equals negative 0.2131. B, based on the scatter plot and the correlation coefficient, is there evidence of a linear relationship? State the critical value from the table and explain how you used it. Well, the scatter plot tells us that the trend does not appear to be linear. They tend to be scattered, and the slope, if there was a line, looks to be 0. The table, we have n equals 7 paired data, and the critical value for that 7 sets of data is 0.754. The correlation coefficient is negative 0.2131. The absolute value of R would be 0.2131, and 0.2131 is less than 0.754. Therefore, the absolute value of R is less than the critical value. And since the absolute value of R is not greater than the critical value, there is no evidence of a linear relationship. The scatter plot does not appear to be linear, and there does not appear to be, and the absolute value of R is not greater than the critical value. There is not evidence of a linear relationship. Is it appropriate to use a linear regression equation to make IQ predictions within the range of the given heights? No, it is not appropriate based on the scatter plot and the critical value table. If not, what should we use? We should use the average Y value. So if we wanted to predict the IQ of a male alien that is 4.7 feet tall, we don't care how tall he is. We should just take the average IQ. That's as good of a predictor as anything. So all we would want to do is take the sum of the IQs and divide by the 7. So add up 200, 221, 216, 203, 202, 220, and 191. That adds up to 1,453 divided by 7 gives us an average IQ of 207.5 or approximately 208 for our IQ. Again, for Mrs. Borlaug, we round the IQ value to the same number of places as the original data. Follow your teacher's rounding rules, please. Here are some student exercises or problems for you to try. Some answers are provided so that you may check to see that you're on the correct track. Remember that if you're doing these exercises for quiz grades, that you will only receive credit for showing all of your work. Thank you for watching, and as always, if you're a Walter State student and need additional help, it can be found by coming by the Math Lab on the main campus in room 222 of the Math and Behavioral Social Science building. Thank you.